In this lesson, we're going to use the Geogebra software program in order to find a regression for a set of data. The regression that we're going to find is actually found visually, so we will be trying to fit the curve that in some way is most appealing visually. So we're going to take a look at a couple of buttons. The first button that we have here is an arrow pointer button, and that'll allow us to select things. The button all the way on the right is the move button, and so if you need to move your axes around, you can actually select this, click on the background, and drag it in a position that's best for you. The button right beside the move button is a place where we will insert a slider into our process. At the very bottom of the screen, there's an input command line, and this is where we can input equations and data points. So the first thing that we're going to do is we're going to input some points to show up on our graph. And so we're going to do that with a capital letter equals and then the coordinate point in parentheses. So we can look at A equals the coordinate point 2, 3. And notice that it placed it in the object location in the far left side and also plotted the point for us on our grid. We're going to input a total of 5 points here. So we'll just type in B equals 4, 5. There's another point. We'll look at C equals 1, 1. D equals 3.5, 3.5. And lastly, we'll look at E as a point of 5, 6. So we have these data points, and it looks like they're kind of lined up, and so we'll take a look at coming up with an equation of a line that goes through them. For this sake, we're going to say that this line is a direct variation line, which means it must go through the origin. And so if I use the fact that it must go through the origin, then it has a y-intercept of 0, so it's either y equals mx or y equals kx if we want to view it that way. What I want to be able to do though is I want to be able to tilt the line along the way as it's coming up with the equation. So we're going to use a slider. So I'm going to click on the slider button, second button from the right. I'll click on a location on the screen where to put it, and I'm going to let this slider represented by the letter K. A couple of other places that you'll notice here is you can set the minimum for the value of K, the maximum for the value of K, and whether you want to increment by 0.1 or some other value if you need it more finely tuned. Okay, we'll just leave it at 0.1 for now. And so I have this slider. It's not connected to anything yet, I've just created the slider. So down on the input line, I'm going to type in y equals k times x. And when we do that, on the left-hand side of the screen, you'll notice that we have an equation of y equals x because currently the slider has a position of k equals 1. Make sure you select the pointer first. If you grab hold of the slider button after you've selected the pointer, then we can actually slide this left and right, and we're adjusting the value of k. So mathematically we're adjusting the constant of variation, or we're adjusting the slope of the line. And the question would be, what visually looks right in order for this slope to make a best fit through those points? Okay. So I think on this one, with the k value of 1.2, it appears that this is the best fitting line going through that data set. And over on the left hand side, the equation is also continually updating, and so even though we moved our slider around, it's updated it to become y equals 1.2x. And so this is how you can input data points on a GeoGebra software, and then also use sliders, and you can have more than one slider in an equation. You can use those sliders to manipulate the effects of the equation on the graph.